Hello everyone, my name is Zhang Zhuhan, and now I will introduce the method that I use to solve the question 2 on homework 11. The homework 2 asks us to find that if we have three functions of v, if we represent the v with tau and omega, whether these functions is autocorrelation functions of a real WSS process or it is a power spectrum of a WSS process. First, let's recall the definition of the autocorrelation functions of a real WSS stochastic process XT. If R tau is autocorrelation of this WSS process, then it is even and R tau is smaller than R0 and its Fourier transform is non-negative. And if SW is a power spectrum of a Whiteside stationary process XT, then it is non-negative all everywhere. So first, if we have the Fv equals to the e to the power of minus abstract of v, first, it may represent autocorrelation functions because this is even. If we substitute the v and minus v into these functions, and we get the same result. And then these functions is decreasing functions with v, so the r tau is smaller than r0. And finally, if we do the Fourier transform to these equations, and we get this. Since alpha is larger than 0, and alpha square and the omega square are also larger than 0, so the equations of this is larger than 0, which means it may represent correlation functions, autocorrelation functions. And second, it may also represent power spectral functions of Watson stationary process, because e to the power of anything is larger than 0. And second, if we have the Fv equals to sine square divided by v square, and it also represent autocorrelation functions because these functions is even because we have both square on up and bottom, and we also have the r tau is smaller than r0 because r0 is the largest. R0 is the largest scenario of these equations, and the Fourier transform is like this. At the graph, we can also find that it is always non-negative. And second, it may represent the power spectrum functions because it's larger than 0, which is easily to proved because sine omega square is larger than 0, and omega square is also larger than 0. And finally, if we have the big V equals to 1 when the abstract of V is smaller and equals to alpha, and the big Fv equals to 0 if the abstract of absolute value of V larger than alpha. First, it can't be represented the correlation functions. First, it is true that the big Fv is even and it is also non-negative, but the Fourier transform of big Fv equals to the 2 times sine alpha omega divided by omega, which is not non-negative because if we choose omega to some values, we get the negative part. And second, it may represent the power spectrum because the big Fv equals to 1 when the absolute value of omega is larger than alpha, which is non-negative, and big F omega equals to 0 when the absolute value of omega is larger than alpha, which is also non-negative. So we combine these two scenarios. We have the big omega F omega is non-negative, which means that it can be spectrum power spectrum functions of WSS process. That's all. Thank you.